So as I was saying, you don't just go in the network and you say, okay, what assets do I have? I have printers, IP phones, web services, users, computers, laptops, smartphones, etc. And then you go ahead and provide the same level of security for all assets. This is not what you have to do. Of course, small companies go ahead and either put in place no countermeasures, or put in place, let's say, common countermeasures, which in general they end up investing money in something which doesn't offer any benefit at all. But that's not a story. But like, medium and large companies, they do a risk analysis. So basically they have to understand which countermeasures have to be applied to which assets to defend them against which vulnerabilities. And they don't implement the same level of security to all kind of assets, because it doesn't make sense. It doesn't make sense not only from the technical point of view, but also from the investment point of view. So the risk analysis, it is required always. It's always going to be done by medium and large companies, and allows for a correct cost to value ratio for possible countermeasures. And that allows the organization to be able to invest more where the case is needed. Like if the organization has, let's say, $3 million a year to invest in network security, then doing a risk analysis, the proper risk analysis the proper way, is going to show them that, hey, in this specific region of the network, or for this specific assets, we need to provide a level of security of 80%. For the other assets, we need to provide a level of security of 20%. So then we're going to divide those $3 million in 80% being targeted towards the assets which have to be better secured, which are classified as confidential, for example, and then the remaining 20% to the other assets, which are the ones which are, let's say, private, for example. So this analysis is always required, and it's always being done in medium and large companies, because otherwise not only you don't know what you have to invest and where, but also you don't have an input of how much should you invest. So I hear this a lot from a lot of companies saying that let's say when I was doing consultancy with my ex-company, I was going there and saying, hey, in order to defend yourself, let's say we were telling them you have to provide a network access control solution to let's say, control differentiated network access for different people and different endpoints. And let's say the total cost of that solution, which was CISCO's Identity Services Engine, for the number of employees that the customer had, it was, let's say, $500,000, so $500,000. And then the company said, oh, that's too much. That's because they had never done a risk analysis. Like, how can you state that $500,000 investment is too much in order to defend billions of dollars worth it in your assets, for example? Those two are not comparable, right? To invest $500,000, it's wrong, and it's too much to invest $500,000 to protect something which is worth it $100,000. But to invest $500,000 in order to protect billions of dollars, that's not too much. That's actually too less. And for the risk analysis to be performed, there are two methods which are commonly used. We have what is called quantitative method, which is based on mathematical algorithms, and this is always used. I said in general, but it's always used. As I was saying, by losing asset X, the company knows it's going to lose up, for example, $5 million, which means the possible countermeasures. If the possible countermeasures cost $400,000 and they reduce risk by 80%, we're going to go ahead and do that. So that's mathematical method for risk analysis. But always, so each company is always going to deploy both a quantitative method and a qualitative method for risk analysis. Now the qualitative method is more subjective, and it's basically used when the quantitative assessment is not possible, like a natural disaster or a terrorist attack. Like if with the quantitative measurement, you can state that if we lose this specific asset or this specific data, which is vulnerable to this specific attacks, and to stop those attacks, we have to implement this security technologies, which is going to cost us this amount of money. This is all numbers. It's all mathematics, and you end up doing that or not doing that. Based on which security level you want to achieve, you're going to invest more or less. But in the cases of, for example, a terrorist attack or a natural disaster, you never know the level of involvement, how much damage can that produce, right? So like, for example, if on a terrorist attack, how can you know if, they're going to attack you and, for example, they're going to take down all of your data centers, or they're going to take down one data center, or they're going to take down portions of the data center, right? And in some cases, there are, as I was saying, because in all cases you end up with a risk which is accepted. Like, take the use case of all data centers being attacked at the same time. Okay, well, nobody's going to take any kind of measures against that specific use case. Okay, so basically you're gonna make sure that the data is safeguarded, and you have copies of the data in different locations, like in 3, 4, 5, 6, 7 locations, depending on the sensitive level of that data. But you never take into account that it's possible that somebody is gonna attack all of your sites at the same time, bring them down at the same time, and delete the data at the same time. You never take into account that. You have taken that into account by using multiple locations to store the data, but then there's nothing you can do about a possible attack that can attack all of your sites at the same time. And even if you would, it's going to cost way too much in order to defend against that kind of attack. So for those use cases, for specific use cases, when you cannot quantify, like, what is the impact of a specific attack and against which assets can that happen, and then you cannot impact also the risk level, then in those cases you do a qualitative analysis, which is basically very subjective. It's subjective, it's no good based on numbers.